In another video, I talked about the origins and the history of the tubing materials used to install built-in vacuum systems, well, the pipe and the tubing. If you know what the difference between pipe and tubing is, pipe is measured by the inside diameter, tubing is measured by the outside diameter. So this central vac pipe is actually central vacuum tubing. It is 2-inch OD. And it's a legacy size from the thin wall steel tubing and fittings, which you see here. This was originated in the 50s to replace your threaded iron piping material. And 2-inch Schedule 40 is a legacy size from that 2-inch threaded iron, and 1.5-inch Schedule 40, same deal. They're the same size inside and out. So that's what vacuum systems used to be installed with 100 years ago, this cast iron threaded stuff. Why are we using a special size instead of just using 2-inch Schedule 40 plumbing pipe? We wouldn't want to use 1.5. That is too small. You're going to get a lot more friction loss and more potential for clogging. But why not 2-inch? This stuff is a little bit bigger. You'd think you get better airflow, right? Well, maybe. I've actually used this for a few systems, and you can get it to work. It's actually quite a bit more difficult to work with. You've got to mark each piece, take it down, cut it on a miter saw, deburr it, and really, if you want to be really thorough about it, if you look at the inside of this fitting, any Schedule 40 plumbing fitting, that hub stop has a chamfer. And so in order for there not to be a gap, which can catch something like a toothpick or a hairpin, you want to chamfer this edge to match that. And you either got to take an angle grinder or this thing and go around a whole bunch of times. And then you glue this together, and then hopefully you don't have that. Because the key to a clog-proof central vacuum, besides using the proper fittings and knowing how to use them, is to make sure that every piece of tubing is glued all the way into every fitting, creating a nice, smooth transition. Because this air and dirt is not getting sucked through the system, it's actually being blown through the system. The vacuum system evacuates and depressurizes the piping, and then your higher pressure air from the outside runs in, carrying nearby dust and dirt in with it. So that dirt and dust relies on the fittings to deflect it in the direction of the power unit that's going to collect it. So any little gap, like if I were to just barely not glue this in quite enough, that is an invitation for a blockage. Maybe it'll never happen. Maybe it'll happen in 10 years. Maybe it'll happen once a year. But if you do that all the way in, you're not going to get a blockage at this connection. So we talked about how to cut this stuff. Miter saw, maybe a sawzall. You got to be really good to get a straight cut with a sawzall. And you got to be even better to do it with a hacksaw. It's almost impossible. We use a pipe cutter. That means if we're on a ladder or in an attic or something, we need to cut pipe. We use this. We spin it around. It's got a little razor blade that's scoring that tubing. And now we've just cut a piece of tubing. So not only does that give us a better joint, it's also much faster. This is much lighter to work with, and it doesn't need to be any heavier than this. This, even in commercial use, lasts for decades unless you get into a really, really high abrasion environment. And that's when you still use metal. So that's why we have our own standard for central vac tubing, and that's why it's worth using the right material for the job. Thank you.